All right, here are solutions for quiz 2, math 211. This first problem kind of modeled off a homework problem where you're building shapes with toothpicks. So here's the first 3 iterations, and you're asked how many small triangles would there be in the 30th iteration. So obviously you don't want to go all the way out to the 30th iteration drawing them. That would take you forever, and the numbers would be huge. But you might be able to recognize some sort of a pattern. Really, what I do in this second iteration is I take the first iteration and kind of build this onto it. So I take this first 1, and I add 3 more to get up to this 4. And here I have my initial 1 and then my second row, which has 3, and then my next row has 5. And if I did the next one, I would have 1 more row tacked on, so I'd get 7 and so on. So really what's going on here is I just have a sum of odd numbers. And as we've seen a couple times in this class, when you take a sum of odd numbers, you get perfect squares. So what's going on is in the first iteration, I guess I could say iteration, triangles. In the first one I got 1, and the second one I got 4, and the third one I have 9, the fourth I have 16. It looks like my pattern is that I'm just squaring the number each time, and in fact I am, and the reason I am is because of this logic with odd numbers. So in the 30th iteration, my answer would just be 30 squared, which is 900. What is the perimeter of the 25th iteration? Well, same idea. I guess I could do iteration and perimeter now. So perimeter, the distance around the outside here, it would be 3 toothpicks. Here, each side is 2 toothpicks long. So 2 and 2 more and 2 more would be 2 times 3, in other words, 6. Here, each side is 3 long, so it would be 3 times 3, aka 9. And the fourth one, if I were to draw it out, each side would be 4 toothpicks long, and 4 times 3 will give me 12. So it looks like in each case, all I'm doing is take the iteration and multiplying by 3. So in the 25th iteration, it would just be 3 times 25, or 75. Maybe I'll write parenthetically sort of where those numbers came from. This was 30 squared up here. Okay, so how many total toothpicks are there? That's a very challenging question. A few different ways you can get there. Let's see, so total toothpicks. In the first iteration here, I got 3. And here I have, well, let's see if we just kind of count them up. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And if I did the next iteration, well, I can kind of think about how many more I would add on. I would add on 1, 2, 3, 4. Well, let's go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 more. So I would be up to 30. So how are you going to find a pattern here? Well, that's kind of a challenge. A couple options in terms of what you do. In the first one, I ended up with 3. In the second one, I got 9. In the third one, I have 18. And in the fourth one, I have 30. So if you think about what's going on here, well, I'm adding 6 to get what most people saw, is that you added 6 here, and you added 9 here, and it looks like you added 12 here. So the amount that I add each time increases by 3. But how does that help me? Well, it turns out that does help you. One way you could get there is you could say that this 3 right here is therefore just 3. And this 9 right here is 3 plus 6. And this 18 right here is 3 plus 6 plus 9. And this 20 is 3 plus 6 plus 9 plus 12. And it turns out you can add up sums like this. You could say, all right, if I were trying to figure out in the 20th iteration, the amount that I would have would be 3 plus 6 plus 9 plus 12, all the way up to, well, let's hear. Here I stopped at 3. Here I stopped at 6, which was 2 times 3. Here I stopped at 9, which was 3 times 3. Here I stopped at 12, which was 4 times 3. Here I would stop at 60. Try to add up that sum. Could use Gauss. Gauss's method would allow you to add this up and figure out what number you're going to write here. I solved it a different way when I was working on this. What I did is I used previous answers, could use Gauss, or maybe over here. In 20th iteration, let's see, how many triangles would I have? Well, the number of triangles I have is just the square of my iteration. So there's 400 triangles. Let's see, each triangle uses 3 toothpicks. So 400 times 3 would give me 1,200. But there's a problem. That's not my answer because I double count some of these. Right? I count these 3. And then if I count these 3, I just counted this one twice. In fact, I would double count every single toothpick except for the ones on the perimeter. So the ones on the perimeter I would not double count, but every other toothpick I would double count. So how am I going to figure that out? Well, how many would be on the perimeter? I know that on the perimeter there would be 3 times 20, in other words 60. So if I take this 1,200 and I add 60 more, I get 1,260. And so 1,260 is what I would have if I counted every toothpick exactly twice. So if I do 1,260 divided by 2, I get 630. I think that'll end up being my answer here. Let me prove that to you using Gauss's method. Gauss's method is I would write this sum again, except I would write it underneath here. And I would do that all the way down until I got 3. And then I'd say, okay, each column sums to 63. And how many columns do I have? Well, I have 20 of them because I'm in my 20th iteration. So Gauss's method would say that the answer is half of 63 times 20, because adding up 63 20 times is just 63 times 20, but that would be twice my answer because I wrote the sum twice here. So instead of 63 times 20, I'd want half of that, which is 63 times 10, which is this 630 right here. So either of those methods will work. I think this way is quicker. This is the way probably most people solved it in our class, which is fine. How many ways can you give someone change for? Change this problem. I made it 120 bucks just so your list wouldn't be quite as long. It's probably already too long. I probably should have made that 100 or maybe 80. But you guys solved 120, so that's what I'm going to solve. I think the easiest way to do this is a systematic list. So let's list these out. Here's my 20s, here's my 10s, and here's my 5s. And let's start by listing the most possible number of 20s, which would be 6. That would be all $120. I wouldn't have any other bills. I could also have 5 20s. Now that's 100 bucks, so I need 20 more. I could get 20 more with 2 10s, or with 1 10, or with no 10s. So really what I have here, if you kind of break these up a little bit, is I have one option that involves 6 20s, and I had 3 options, it's not a W, that involve 5 20s. I wonder if there's some sort of pattern going on here. What if you had 4 20s? Well, if you had 4 20s, that's 80 bucks. So I need 40 more dollars. I could get $40 with 4 10s. I could also get $40 with 3 10s. I could also get $40 with 2 10s, and 1 10, and 0 10s. And if I go and I count those up, looks like I have 5 ways. 1 way, 3 ways, 5 ways. It kind of seems like there's a pattern developing here. Let's make sure that that pattern holds true. What if I had 3 20s? Well, if I had 3 20s, that would only be $60, so I'd need $60 more. So the most 10s I could have is 6. Note that all that's going on with the 10s is I'm decreasing by 1 each time. So here I started at 2, here I started at 4, here I'm starting at 6. I'm starting 2 higher. I think there's going to be 2 more ways because I'm starting 2 higher. Let's see how that plays out. 3 20s. I get there with 5 10s. I could get there with 4 10s. I could get there with 3 10s. And 2. And 1. And 0. So now if I go through and I count up those ways, I think I'll have 7 listed here. So I don't even need to list them out anymore because I can kind of see what's going on. If I only had 2 20s, then there would be 9 ways here. If I had 1 20, there would be 11 ways, and if I had 0 20s, there'd be 13 ways. What I'm saying is that since I recognize the pattern, I'm not even going to write them out anymore. I got 9 ways, 11 ways, and 13 ways. So my answer is 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. It's the sum of the first 7 odd numbers, which we know from above is 7 squared, which is 49, or you could just add those up and get 49. 49 ways would end up being the answer. And I guess that ends this quiz.